Okay, welcome to the demonstration of the data pipeline project. This is the first assignment of the Big Data Engineering course. So before we start to run the data pipeline infrastructure in the project to collect the real-time data and data stream, we let me talk about the ABI, the information of the ABI that I gonna use in task number 3 to generate the fake data. So the first ABI is about the CoinGecko ABI. So I use this ABI to collect the cryptocurrency market data in real time. And the second thing is I gonna use the Google Gemini AI to simulate the human behavior in trading activities. So there could be three endpoints. The first endpoint is about the simple price. This is the CoinGecko API to retrieve the price of the cryptocurrency based on specific currency. For example, one USD is going to be approximately 69,000 US dollar. And I use this API to create a pay-in transaction. So this one is a fake data that I gonna generate. So I need to use the real-time price to generate the pay-in transaction, which is I will talk later in the demo. So the next thing is the coin market data. So this API is not only return the price, but it's also return some market data like market capitalization of the coin, the total volume in the past 24 hours, and the percentage price change in 1 hour or 24 hours. So those information is useful to collect and visualize later. Okay, and the third API is the Gemini chat. So I use this API to build the first I use the start chat method to build the context of the conversation, and then I send the prompt to retrieve the answer from the AI to simulate the decision um, of the user of the human to making the trading transaction. I will show it later. Um, so let talk about the practical implication of the project. So when we talk about the cryptocurrency, this is the market that this is the it could be the industry and um, from the time that the Bitcoin were introduced, it's transformed the market landscape. So the number of transactions of buy and sell today is gonna reach maybe 1,000 per second of the transaction in many platforms like Binance or Coinbase. So with that big volume of data, um, it could be the compelling subject to research and study in the big data analysis. So in this project, I try to establish the connection between the crypto market data and the trading behavior of the investor. So when we have this connection, we're gonna have the insight about the potential and the core values of the crypto industry, and uh, we can get the benefit from that um, for the trading platform and for the trader to trade uh, more more carefully, and to have the trading platform to make effective marketing strategies and build a cost-effective infrastructure and many more things. So let's talk about the use case. So let's assume that this data pipeline project is hosted by the cryptocurrency exchange platform like Binance or Coinbase, and this company have the core feature like allow the user to register the account, which contain the basic information, and allow the user to buy the cryptocurrency. So that is where the pay-in transaction comes. So we're going to generate the fake user account data and the fake pay-in transaction. So with this uh, data stream, we collect all of that and feed into um, the Kafka cluster. And then using the Kafka Connect to sync those data into the NoSQL database like Cassandra. Okay, so um, so with that data that we collect, there could be three main use cases that I will talk about. Maybe there could be more, but I will focus on three use cases. The first one is to predict the market trends. So with the historical data that we collect, we can build the useful chart and doing the statistical analysis to know the pattern about the user behavior and the pricing behavior. And then we can use this to notify the user for about the potential price surge and decline. And another thing is we can also predict the traffic sprite on the platform. So we know the pattern. We can predict that as specific event, um, when the price is go up, it's gonna bring a lot of traffic into the platform to make a transaction. So we can predict that event. We can help the platform to prepare to add the additional server capacity, and also give the transaction fees to optimize the performance and profitability of the trader. Okay. The next use case is about fraud detection. So with the real-time data monitoring, we can identify the account who is doing the wash trading, and also identify when the DDoS attack is happening to mitigate that attack. And the final thing is about the optimization of the market strategies. So with the historical data, for example, like we collect the pay-in transaction that the user is made, and we visualize into the charts. So with that information, we can identify the trading habit of the trader and the major coin in their portfolio. So with that information, we can build a system to generate the email campaign promoting for example, like the reduction of the trading fee, and also send a newsletters about the coins that related to the major coin that they have in portfolio in terms of the technologies like proof of work or proof of stake. um, the second scenario is the promoting the new cryptocurrency as well. So with the data that we collect about the user, we know that their trading taste is about it's a risk trader. So they could interesting in the new coin or the coin that can make a profit faster. So we can build the in-app notification or the advertisement and send the, the information about the new cryptocurrency to those users. Okay. So with that with those two use cases, we can with the data applied to those use case, we can attract the new user, retain the existing user, and maximize the platform engagement. Okay, so that's enough for the information about the practical implication of project and API. Next thing is before we move to the setup step, let me introduce about the infrastructure. So we're gonna have a lot of container. So the first container is the zookeeper and three Kafka broker and one Kafka manager and one Cassandra database. So the Cassandra database is going to be bootstrapped by the CQL script, and the location of those script is in the short slash CQL, which is this location. So it's gonna automatically load this one into the container and run the CQL automatically to create the key space and the scheme, the table scheme. And the second thing is the Kafka Connect. So we use the Kafka to collect the data, the message from the topic, and we sync those data into the Cassandra database. So we need the connector. So the connector will be created automatically in this script, which is this one inside the source folder. We're gonna have many script, many connector. The first one is, for example, the weather sync connector to collect the weather data and insert into the Cassandra database. The second is the user sync, transaction sync, and pricing. Okay, so this script is gonna make the HTTP request to um, the Kafka Connect host to create the connectors with the mapping information and the topic information. Okay, so the Kafka Connect needs to communicate with the broker and the Cassandra. So to make sure that the Docker Compose is gonna run smoothly, I will specify that the Kafka Connect is depend on those container and make sure that those container is healthy before the Docker gonna up and running the Kafka Connect. So to define that dependency, let's look into the Docker Compose. So this Docker Compose, we're gonna have the Zookeeper, the three brokers that I mentioned before, and one Kafka manager, and we will see that the Kafka Connect is depends on Zookeeper to be started, but it will waiting for the brokers and the Cassandra DB to be healthy. So the Cassandra DB is here. So to indicate that the Cassandra DB is healthy, we have the health check to run the CQL shells to select the local time. So this health check going to be run 5 times to make sure that the Cassandra DB is healthy. And then if everything is healthy, the Kafka Connect is run. Okay, and let's talk a little bit about the networking. So Zookeeper, brokers, and Kafka Manager definitely stand behind the Kafka network, which is the bridge network in Docker desktop. And there are some port that's going to be exposed into the external network. And one thing to be noted is about the JMX matrix. So those ports is gonna export from the Docker container, and the Kafka manager is gonna communicate with the brokers via those ports. to get the matrix data and visualize in the Kafka Manager dashboard. And sorry, this one is to be the Kafka Connect. So the Kafka Connect is gonna connect into two different networks, the Kafka network and the Cassandra network, to communicate with the Cassandra and the three brokers here. So it's the Kafka Connect needs to communicate with this one. Okay. So that's enough for the networking information. So let's start. Um, let's open the terminal. So we're gonna run the command on the this directory, which is this one. And um, let's start. In the first step, we're gonna build the infrastructure component image. So those images include the Kafka, the CMark, which is the Kafka Manager, the Kafka Connect, and the Cassandra Bootstraps. I want to build it myself instead of using the public image because when I build it myself, I make sure that the Docker file and the script of the link to the Docker file is gonna run and download the appropriate base image on the specific architecture. So in my personal computer here is I'm using the AMD, so I already make sure that those Docker image after build is gonna get the base image that run on, for example, ARM, like a Apple Silicon chip or something. So I want to build it myself to make sure that the container is running effectively on the architecture. Um, we build the Kafka first, okay. Next, we build the CMark. We will see that the Kafka is built successfully here. So the CMark is also set. Build the Kafka Connect. And Kafka Connect successfully, okay. Okay, CMark also good. And then we're gonna create a Kafka network. Create a Cassandra network. Okay, everything good. We're gonna compose the Docker compose YAML file with the project name is the My Data Pipeline. So we will see that Dow container is running immediately, but the Kafka Connect is not running yet because it's waiting for the broker and the Cassandra to be healthy. So it needs to wait for a little bit. So we will see that the Cassandra is still up and running. It's going to initialize some port, some stuff to initialize. Okay, let's wait. Oh, so you see that the Kafka Connect is running now after the broker and the Cassandra Bootstrap is healthy. It's gonna run. Okay, let's move to the next step. Step number 3. I want to go to the Kafka Manager to see the information of the Kafka cluster. So I'm gonna open this one. I will use the username and password here to log in. Okay, just sign in. Add cluster. The view profile is the default. You keep a container and the port. Enable the JMX Okay, pull the consumer information and move to the self. So we will see that there's a lot of topics have been created automatically. So we have the weather, we have the user, we have transaction topic, we have live topic, and yeah, we have the topic of the Docker Connect. So the Docker Connect is successfully launched. Okay, Kafka Connect is launched, which is good. Let's go to step number 4. We're gonna make HTTP request to Kafka Connect to get the connector status and information. Okay, let's copy this one. Yeah, let's open one. Pass this in here. Run it. So yeah, you see that the Twitter thing is running. Let's see another topic. Let's see another task. The user sync connector is running. Good. Pricing is running. Good. This one also running. Weather. Weather also running. Okay. So we have those connector. So which mean that this shell script is running successfully. Okay. And Kafka Connect is still running. Okay, good. We move to the step number 4. So we open another terminal. Okay, we open another terminal and we create a client of the Kafka cluster. So we're gonna have the open weather producer to produce the weather information and open weather consumer to consume the message that's generated by the producer and bring into um, the terminal data visualization container factor producer factor consumer price corn price producer and corn price consumer. Okay, let's be one by one. Do it. Good. Next. Okay, let's speed up. Everything is running very fast. Producer. Okay, it's gonna create customer. Okay, so we have everything here. We have the image. Okay, let's compose the clients, the Kafka cluster clients. So this is another Docker file next to the Docker compose file. So this one is gonna contains the weather producer, weather consumer, fake producer is gonna generate the transaction and the user registration fake data, and fake consumer to consume the data generated by the producer and bring it into the terminal, the console. Price producer to get the live price, live market data of the coin, and coin consumer. Okay, let's run it. Okay, so we will see that the factor producer, the weather. Okay, um, the weather successfully get the weather from London City and send into Kafka, and weather consumer successfully retrieve the London weather and bring it into the terminal. Okay, factor producer. We let's see. So Gemini is running. It's predict that the customer take 300 seconds to before he make the decision. Okay. Okay. Let's talk about the how I run the weather producer. So we will see that the weather location here is this one is the environment variable, so it's going to be read by the container. So I said that there's four city: Vancouver, London, Ho Chi Minh City, Melbourne, and all of that is separated by the comma. So we will go to the weather producer. We will see that the weather locations gonna be split into the list of location, and we're gonna loop one by one and get the data from those city and send to the Kafka topic. Okay, and the next thing is the factor producer, which is task number two. So for the task number two, I'm gonna generate the let me see. Um, if you go into the factor producer, you will see that it will generate the fake user registration data and fake user transaction data. So let's go to go to the detailed implementation of the fake data generator. Okay, so this method is gonna generate the fake user data using the fake library. So we're gonna have more than 10 fields um, about the user. For example, like a user ID using the UUID version 4, fake name, fake address, fake job, sex, date of birth, years, all of those information, basic information about the user, and we return into um, we're gonna send it to the user topic. And the next fake data that I want to generate is the pay-in transaction. So let's talk more about the pay-in transaction. This pay-in transaction is a transaction that the user, um, the existing user in our application, which will be picked up randomly by the fake API, fake library. We're gonna pick a random user, and that user is gonna buy the cryptocurrency. So that's this pay-in transaction contain the source currency, which is USD, and the destination currency, which is the cryptocurrency that the user want to buy. And uh, let's see. The random user ID is gonna pick from the Faker library, and source currency is also picked randomly. So amount also picked randomly. So currency, destination currency also pick random coin, and we use the simple price API that I already introduced in um, earlier. So we get the price between the source currency and the destination currency, and we build the exchange rate. We use the random generated stroke amount multiplied by exchange rate. We're gonna get the destination amount. So with our information, we send to the Kafka cluster. Okay, and one thing to note is the this one. Why do we have the delay here? So if we don't have the delay, the the server, the container is running and generate hundred of transactions per second, which is the meaningless thing. What I want to do here is I want to simulate the time that the user, the real human, um, take time to thinking about the profit, the risk, and the news and many things more before making the transaction. So the human he want to thinking carefully before making a decision. So to generate the time that the human gonna thinking, which means that this price is suitable for the people that who want the short-term trading and quick profit. So the people in short-term trading and quick profit can buy and sell the Ethereum. But Bitcoin. So we know that the value of Bitcoin is much more expensive than the Ethereum. One Bitcoin is about more than $60,000. So there's only one time that Bitcoin go over the 1% of price change, and most of the time is just staying around with the blue light. So which mean that the Bitcoin is a stable level, is a more stable level than the Ethereum. And Bitcoin can be classified as the stable assets, so it's suitable for the long-term investment and personal hold, like gold, yeah, similar to gold. We can hold Bitcoin. Um, okay, let's move to the next plot that we have. Is this is the bar chart. So I want to compare about um, the market capitalization of the Bitcoin and Ethereum. So we can see that there is a in terms of the market capitalization. Um, the interesting thing I found is market capitalization between Bitcoin and Ethereum is 4 times different. It's, um, but the volume of the trading between those two coins is not much different. It's just less than 2 times different. So what I conclude from this chart is um, the price not give the Bitcoin advantage in the market. So the taste and the demand of the investor in both coins are almost the same. So Bitcoin attract the trader, and there's no possibility that the Bitcoin will become the monopoly in the cryptocurrency market. Okay, let's move to the pay-in transaction data that we have. So I'm gonna print out the pay-in transaction. We have the user ID, we have the price, we have the time. So we can see that yeah, some new transaction in the 27 November uh, with the source currency USD and destination currency is the Bitcoin. So we have new transaction over here. Okay. We also have new transaction of the Ethereum as well. Let's see. Okay. Yeah, we have some transaction in 27 as well. Let's move to the next plot. This plot is about the pay-in transaction that the users in the system make every per minute. So this chart is quite noisy, so it's difficult to analyze. So we're gonna spot it in the next chart. So after we smooth it, we can see this plot is about to compare the number of the Bitcoin and Ethereum transaction per hour. So the blue line is the number of the transaction per hour, Bitcoin transaction per hour, and the red line is the number of transaction per Ethereum transaction per hour. And what interesting that I found here is that I found that the chart number A and the chart number 5 have the same behavior. Uh, okay, let me show you this one. So we can see that's from the 21st to the middle of the 22. We see the number of transaction the number of the percentage is going up, and the number of transactions also going up. And when the percentage of price change sideways, the number of transactions also sideways. And similar to this behavior, we see it drop. The percentage of price change also drop, and we see the number of transactions also drop. Okay. Let's move to the next plot that I found. Um, this those two plot is about the top active user and the top highest spender. So I just want to list the top 10 user that who make the most number of transactions and the most who spend the most of amount to buy the cryptocurrency. And the interesting thing I found is there's not much difference between the user. So the difference between them is insignificant, which means that there is no um, trader who have the suspicious activity. Let's move to the next plot. So the final plot is about I want to see as which price of the Bitcoin the user make the most number of transactions and ask which price of Bitcoin that the customer gonna make least number of transaction. The second plot is ask which price of the Bitcoin that the customer spend the most money, and ask which price of the Bitcoin that the customer spend least money. And with these charts, I found the matrix here. So at 99,000, it means that at 99,000 USD, the user make the most transaction, 46 transaction, and at the $95,000, the user make the least transaction between one transaction, and at the 94,000, the user pay the most. They spend 60,000 of dollar, and at the $95,000, the user spend the least money, only 13,768 USD. So this is all about the demonstration of the data pipeline project. Thank you for watching. Let's run the command one by one. Run it. Okay, so we have a lot of data here. We have Ho Chi Minh City, right? Maybe we can get London as well, so we can see. Yeah, we have London. We have the London weather. We can have Melbourne. Okay, run Melbourne. Yeah, we have Melbourne data. Okay, so I interested in the Ho Chi Minh City. Okay, so I want this. I want to run it. Okay, and so we will see the weather data recorded has been visualized into the line graph in here. So the y-axis is about the temperature, and the x-axis is about the time. So we can see the time will change in different days, and today is going up a little bit. I also have the humidity. Okay, so this is the humidity graph of the Ho Chi Minh City in different days. That is about the weather, the weather data that we collect. Let's move to the more interesting data that we have. First one, I want to show the Bitcoin real-time market data. So we're gonna get the Bitcoin uh, based on the USD price. Let's run it. So we get a Bitcoin here, a lot of data, and I think those information that's showing into this table here, we have some useful information like the current price, which is the price in USD. Um, the market capitalization is the total outstanding coin, the volume of on outstanding coin that had been traded. Total volume is the amount of the coin traded in the past 24 hours. A price change every 1 hours. There's a lot of information about the market data, but we only focus on some of them: the current price, the market capitalization, total volume, and price change. Okay, let's move to the next graph. So this visualization is we have two subplot here. The first one is showing about the current price of the Bitcoin market data in the Bitcoin market data. So which also knows at the current price of the Bitcoin in USD. We get the data every hour from 21st November. And the second one is in the same time frame. We also visualize the total volume in the past 24 hours of the Bitcoin in specific time. So the price is going up and down, and the volume here. So what does it mean with those volume? It means that if the volume bar is high, the high bar represent the active market. So the more high bar is indicate that the more users in the market buy and sell the Bitcoin. And if the lower bar indicate that the coin market, it means that not much users buy and sell the Bitcoin at this time. Okay, so what interesting I found here is I put those two plots close together because I can see the same the connection between them. So from the beginning of the 21st November, I can see that the volume going up a little bit, going up, and the price of the Bitcoin also going up. And from the midday, maybe early 23rd November, the volume is going down, and the price is also going down, and it's create a local bottom here. So and then the volume is going up again. We can see the volume going up again, and the price is also going up. Okay, so this is the connection between the those two plot that I found. So that is interesting things. Um, okay, and the next thing is about the Ethereum real-time market data as well. So I'm gonna run it. You're gonna show it as well. So yeah, similar to Bitcoin, we have the Ethereum based on USD. Um, so I also have the same visualization about the Ethereum. So this the first plot is about the price of the Ethereum in every hour from 21st November, and the second plot is about the volume of the Ethereum from 21st November as well. So I also see the interesting that I found is the correlation between the volume and the price is also hold evident for the Ethereum. So we can see that from 21st November to 22 to the mid of 22 it's going up, the volume going up and the price also going up. And then the price drop a little bit from the volume drop from the 23 to 24, so we can see that the price going down. Okay, and that is the connection between uh, the the volume and the price. Okay, and the next graph is about the I want to compare the um, I want to compare two index of the Bitcoin and the Ethereum. That is about the price change percentage per hour. So what does it mean about this graph? We can see that the green line is represent the percentage of price change of the Bitcoin, and the red line is the percentage of price change of the Ethereum. And we can see the small blue dot here, the horizontal line here, in the location is the zero, which means that if if the percentage of change fell into this line, which means that the coin have no change at all, no price change. If the percentage of change is far away from the zero blue line here, it means that this coin have a big change in price, and the lower value indicate that this coin is have a little bit change, insignificant price change. Okay. The positive value is the coin is gonna the price raise, and the negative value is about the price drop. Okay, and the interesting thing that I found from this graph is we can see that um, there is four time of the Ethereum go over the 1%. So there's a purple line here, 1% of change, and we can see the Ethereum go further from this line four times. So which mean that the Ethereum is the coin that easy to get affected by the trading activity, and the price chain is um, have a large difference between the price. So it fluctuates, which means that this price is suitable for the people that who want short-term trading and quick profit. So the people in short-term trading and quick profit can buy and sell the Ethereum. But Bitcoin. So we know that the value of Bitcoin is much more expensive than the Ethereum. One Bitcoin is about more than $60,000. So there's only one time that Bitcoin go over the 1% of price change, and most of the time is just staying around with the blue light. So which mean that the um, Bitcoin is a stable level, is a more stable level than the Ethereum, and Bitcoin can be classified as the stable asset. So it's suitable for the long-term investment and personal hold, like gold, yeah, similar to gold. We can hold Bitcoin. Um, Okay, let's move to the next plot that we have. Is this is the bar chart. So I want to compare about um, the market capitalization of the Bitcoin and Ethereum. So we can see that there is a in terms of the market capitalization. Um, the interesting thing I found is market capitalization between Bitcoin and Ethereum is 4 times different. It's, um, but the volume of the trading between those two coins is not much different. It's just less than 2 times different. So what I conclude from this chart is um, the price not give the Bitcoin advantage in the market. So the taste and the demand of the investor in both coins are almost the same. So both coin attract the trader, and there's no possibility that the Bitcoin will become the monopoly in the cryptocurrency market. Okay, let's move to the pay-in transaction data that we have. So I'm gonna print out the pay-in transaction. We have the user ID, we have the price, we have the time. So we can see that yeah, some new transaction in the 27 November uh, with the source currency USD and destination currency is the Bitcoin. So we have new transaction over here. Okay. We also have new transaction of the Ethereum as well. Let's see. Okay. Yeah, we have some transaction in 27 as well. Let's move to the next plot. This plot is about the pay-in transaction that the users in the system make every per minute. So this chart is quite noisy, so it's difficult to analyze. So we're gonna split it in the next chart. So after we smooth it, we can see this plot is about to compare the number of the Bitcoin and Ethereum transaction per hour. So the blue line is the number of the transaction per hour, Bitcoin transaction per hour, and the red line is the number of transaction per Ethereum transaction per hour. And what interesting that I found here is that I found that the chart number A and the chart number 5 have the same behavior. Uh, okay, let me show you this one. So we can see that's from the 21st to the middle of the 22. We see the number of transaction the number of the percentage is going up, and the number of transaction also going up. And when the percentage of price change sideways, the number of transaction also sideways. And similar to this behavior, we see it drop. The percentage of price change also drop, and we see the number of transactions also drop. Okay. Let's move to the next plot that I found. Um, this those two plot is about the top active user and the top highest spender. So I just want to list the top 10 user that who make the most number of transactions and the most who spend the most of amount to buy the cryptocurrency. And the interesting thing I found is there's not much difference between the user. So the difference between them is insignificant, which means that there is no trader who have the suspicious activity. Let's move to the next plot. So the final plot is about I want to see as weak price of the Bitcoin the user make the most number of transactions and ask which price of Bitcoin that the customer gonna make least number of transactions. The second plot is ask which price of the Bitcoin that the customer spend the most money, and ask which price of the Bitcoin that the customer spend least money. And with these charts, I found the matrix here. So at 99,000, it means that at 99,000 USD, the user make the most transaction, 46 transaction, and at the $95,000, the user make the least transaction, which means one transaction, and at the 94,000, the user pay the most. They spend $60,000, and at the $95,000, the user spend the least money, only 13,768 USD. So this is all about the demonstration of the data pipeline project. Thank you for watching.